You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Since its inception, Amazon Web Services, or AWS, has been the best place for customers to build and run open source software in the cloud. AWS is proud to support open source projects, foundations, and partners.
Hello, and welcome to an on-the-road episode of the New Stack Makers. I'm Heather Joslin, Editor-in-Chief of the New Stack, and today we're at JupyterCon in lovely San Diego, California. And today we're going to talk about Project Jupyter, the Jupyter community, and we're here with Brian Granger, who is co-creator of Project Jupyter, and also Senior Principal Technologist at AWS.
Hi, Heather. Thanks so much. Really great to be here.
Great. Thank you. Thank you for joining us. Let's jump in with talking about the beginning of Jupyter Notebooks. I know it originally started with the IPython notebook.
Yeah, would love to walk through that. So go all the way back to the late 90s. And I was a grad student in physics at the University of Colorado Boulder. Mm-hmm. And one of my classmates, Fernando Pérez, we became good friends there. And I graduated from grad school, finished my PhD in 2001. Fernando spent another year or so. Right after I left, he created IPython, not the notebook, but the interactive shell. Mm-hmm. And both of us grew up in physics using Mathematica. Mm-hmm. And when Python started to come on the scene, it wasn't very long before Fernando initially, and then myself as well, really wanted that notebook experience, but in Python. It wasn't for a few years later that I got involved, though. I was a young professor at Santa Clara University. Fernando visited my family and I, and we stayed up one night talking, and that's really where the initial push and vision for having a web-based notebook in Python came from. And then the short way of saying it is that it took us from 2004 all the way till 2011 to build the original version of the IPython notebook.
Okay, and that evolved into Jupyter Notebooks. And what was Jupyter Notebook? And what was the problem it was intended to solve?
So do you mean Jupyter or IPython originally?
I guess both. Actually.
Yeah. So when we got started, it's hard to imagine a world where data science, AI, and machine learning wasn't really, hadn't become what it is today. Mm-hmm. It was just starting to emerge. And so at the time, that was we were not thinking about that at all. We were really thinking about research and education. Mm-hmm. So my own research was in theoretical and computational physics, and I was doing research in that area, and I literally wanted the notebook to exist so I could use it with myself and my students. Mm-hmm. And really, so it wasn't for software engineering, it wasn't for building applications, it was for solving hard problems that require human reasoning and thinking, really messy problems. Mm-hmm. And that was the original use case, and I think continues to be the use case for Jupyter today. Mm-hmm. When you look back on especially the creation of Jupyter, what do you think are some things that the team got right, and what are some things that you would change if you were to do it over, or realize you need to change as time went on? Oh, that's a great question. So something that I do think we got right is, and I'll tie it back to my training as a physicist. So when you're in physics, you're trained to think in a particular way and build systems in a very deliberate, slow, careful way. Mm-hmm. I don't know how else to say it. And so when we started to approach Jupyter, we spent a lot of time, many, many years, trying to understand what would the needed building blocks be for this system. And how do we make those building blocks reusable, extensible, and modular? And it led to good engineering, I think, but for us at the time, it was more how we had been trained to think as physicists. For example, Newton's equations are very modular and extensible. You can model pretty much any classical system in the universe using Newton's laws. Same is true of quantum mechanics or special or general relativity. And so we wanted to have a very small number of building blocks that solved a large number of problems. And I think we got it right, that we've got the notebook format for Jupyter notebooks. We've got the kernel message protocol. And then we have a bunch of other sort of higher level building blocks on top of that, such as the different APIs of Jupyter Server, Jupyter Lab extensions, and things like that. So that modular, flexible, extensible architecture, I think, is one of the things we got right.
Okay. And what are some of the things that you looking back, realized might have been something that you needed to approach differently?
Yeah, so that's, I think on that side, it isn't as much on the technical software side of it as the community and governance side. When we started out, we obviously had no experience in building open source communities, in all the different dimensions of open source governance that you end up dealing with in the long run. And I would say at different stages along the way, we had to reconsider Jupyter's governance model and how the community was being run. And I would say we didn't do a great job, and that by the time we started to do that, it was too late. And we should have, dove into that earlier than we did. And this is challenging, right? You start out with an open source project. It's more like a hobby with a small number of people who all know each other. And then you wake up one day and realize, oh, wow, this is no longer a hobby. There's a lot more people here. There's corporations involved. And we were slow to address those challenges.
Yeah, it's the constant dilemma of open source. It starts as something that, as you mentioned, like almost like a hobby, and we certainly know a lot of open source projects are being maintained by people, unpaid hobbyists, in many ways that companies depend on. I want to get a sense of when you look at the landscape now. I mean, there's definitely a Jupyter ecosystem now. People are building on it in the same way people, build on Kubernetes or build on containers or whatever.
Yeah.
How would you define like the era Jupyter is in right now?
The current era. So it's we're not alone in this.
Yeah.
I think the era that we're in right now is all of us, everyone is trying to figure out what do we do with AI?
Yeah.
And that's a really exciting challenge. It's not one that we were particularly paying attention to in terms of the open source project, but it's one now that we're facing head on and really diving into that. And I would say, for Jupyter, so for example, in traditional IDEs that are focused on enabling users to build, test, deploy, debug applications and other software systems, I think we're starting to have a decent outline of the role of AI in that. That space has progressed very quickly, and a good fraction of software engineers are now using that on a daily basis. What's interesting about Jupyter is that even though it looks an awful lot like one, it's not an IDE. The goal of Jupyter is not to build, test, deploy applications and software systems. Jupyter is a tool for thinking, for collaborating, and for sharing knowledge. And we're trying, I think in practice, we're deliberately going slow to ask questions about what does it look like for AI to help us think? What does it look like for AI to help us collaborate with each other? What does it look like for AI to help us share knowledge with each other? And so for us, I think in the Jupyter community right now, we're getting to the point where we're starting to see what the right questions are. Mm-hmm. I don't think we have the answers yet, but we are getting to the point also where we now have some software building blocks that we can use to validate, test questions, develop more questions, and iterate.
Mm-hmm. What issues has the open source community not fully solved pertaining to scale in your view, in terms of the Jupyter community specifically? Or, I mean, what do you see as like the next challenges in that?
And can you say a little bit more about what you mean by scale? Do you mean in terms of technical complexity, community size?
Technical complexity, I think probably.
Yeah, so here on the technical complexity side and the scale, Jupyter is a fairly large open source project. There's, I don't know the current count, but certainly over 100 different GitHub repositories across around a dozen different GitHub orgs. Mm-hmm. And it's a lot. Even if you look at not just the code, but for example, GitHub issues. Mm-hmm. We have multiple GitHub repos with thousands of issues. And that's really daunting. I think right now, even though Jupyter is a tool for thinking and collaborating, the people building Jupyter are largely software engineers, and mm-hmm. we're doing software engineering. And so on that, we're, I think, feeling really charged up mm-hmm. by being able to use AI to build Jupyter now. Uh-huh. It's enabling us to get a lot more done while still having as much or more fun. Yeah. And that feels wonderful. Mm-hmm. We're still learning what it looks like to use AI to build open source projects, mm-hmm. but if you look at the velocity of everyone, there's a significant change mm-hmm. In the last year, in particular, around that. And what's interesting from the sort of scaling perspective is what that's starting to do is change our calculations about resourcing, prioritization, technical debt, sunk costs. Mm-hmm. So for example, I did a quick demo or sort of prototype and test of one part of our code base. Jupyter Server's sort of the heart of a lot of what Jupyter has. It's currently written Python. It's been around a long time. It's battle tested, mm-hmm. but it has a number of problems. And so I asked an AI coding agent, basically said, I'd like you to look at this part of Jupyter Server, extract an open API specification, and then re-implement the server in a different language. In this case, I chose Go just for fun. Mm-hmm. And then once you do that, and this was not just a single prompt, there was multiple prompts, please write a test suite. And it took about a half an hour until I had a completely new implementation of that was following this open API specification and had a test suite with 70% coverage, right? Previously, for us, thinking about rewriting Jupyter Server from scratch, we would have dismissed immediately. It's mm-hmm. absolute insanity, right? We have way more important things to do. It's battle tested. And all of a sudden, it's an option. Right? Yeah. And so the way you can think about technical debt, sunk costs is different. Mm-hmm. And I think for large open source projects like Jupyter, in a sort of technical sustainability perspective, that's going to play a really important role, and I think really change the game for us.
The flip side of AI and open source is that we have heard of projects getting a lot of pull requests that are AI generated or AI. The velocity of the developer who makes the changes, does the work. It makes introduces new features. I mean, that could speed up, but also you can get pestered by a lot of
you can get AI slop. Right?
Yeah, exactly.
You can get that. Yeah. So interestingly, Jupyter is not getting a lot of that.
That's great.
I think, thinking about back to like the traditional hype curve where it goes up and down, there's a trough of disillusionment, and then it slowly becomes productive. At this point, Jupyter is far past all of that. It sort of is on that plateau of productivity. And because of that, it's not a sort of a highly popular target for new contributors. Now, that creates other challenges for us. We'd like to recruit new contributors, and we may not be the first project on their list. But it does mean we've not seen a lot of sort of AI slot pull requests coming in, that type of thing.
I neglected to mention that you are also co-creator of Altair.
Yes, the statistical visualization library. Created that with Jake Vanderplas.
Can you tell us a little bit about Altair? What does an ideal ecosystem look like around that in your view?
Around Altair and data visualization?
Yeah.
So I should be transparent. I haven't worked on Altair in years.
Okay.
And Jake and a number of other people have taken that on and are doing incredible things with it. I'm trying to think. It's been many years since I contributed. So I can probably comment on the original vision.
Sure.
But in terms of its current state, at most these days, I'm a happy user of Altair occasionally.
Okay. So so what was the original vision around Altair?
Yeah. So we grew up using, as scientists, Matplotlib, and I had been using Matplotlib for years. Certainly Jake had been. There was, what we started to see was that tabular data sets were becoming more and more important. And Matplotlib is not really oriented towards tabular data sets. You can do things with Matplotlib and tabular data sets, but it's not optimized for that. And I think what we saw happening at the time was a number of different options in Python for tabular data visualization. And it felt like everyone was trying to figure out what the right visualization grammar was. And, you want to be able to make bar charts or scatter plots or the different types of plots. And we became aware of some of the work that Jeff Hare's group at University of Washington was doing. Jake was at the University of Washington at the time, and we were really attracted to the visualization grammar that Jeff Hare's group had come up with. It felt more, I guess the way I would say it, it felt more like an actual grammar rather than pre-composed sentences. Right? A lot of the other tabular visualization libraries, it felt like there was like a pre-composed sentence for making a scatter plot, and it could make a scatter plot. But if you tried to identify what are the lower level building blocks, they either weren't there or they were really low level. And so with this underlying visualization grammar and with Altair, we were very interested in this sort of very modular, flexible grammar where it was very easy to express different types of visualizations using a small number of building blocks.
And one last question. Project Jupyter won the ACM Software System Award, which puts the project in the company of Unix, Java, and the World Wide Web, which we've all heard of. What responsibility comes with that level of recognition? And what does success look like for Jupyter, say, over the next 10 years?
So part of this is an acknowledgement that Jupyter, while many of us enjoy it like we would a hobby, it is no longer a hobby, right? We have entire industries, academic research, education, depending on Jupyter on a daily basis. And there's a lot of responsibility with that. Now, the responsibility is not carried by any individual. It's more distributed across all of us in a very odd way. I think along with that comes, for me, questions of sustainability. When large organizations, whether they're for-profit corporations or large research collaborations or universities, are building on top of Jupyter, they're taking a bet, right? They're writing Jupyter notebooks, and they want those notebooks to run a decade from now. And so there is that question of sustainability, both from the technical side as well as the governance and community side. And so I do think that sustainability question started to come into focus with the ACM Award. That wasn't the only piece of it. There's been many other sort of things that have happened along the way. So I think sustainability, also, looking forward, competition is something we think about. When we started working on Jupyter, it was an empty space. Right? There was traditional IDEs that were built more for languages like Java and C# and C++, and then there was Jupyter.
Yeah.
And that's no longer the case, right? And even the IDE space has become even more busy with the arrival of generative AI. And so we are aware of competition. We feel like Jupyter, because we're not focused on software engineering per se, Jupyter is still very unique. We're focused on more use cases that are similar to research, education, or their generalizations in terms of what we call thinking, collaborating, and sharing knowledge. And so we believe Jupyter is as relevant as it has ever been, but that's something we take serious. If there's anything that keeps us up at night, is that Jupyter dies a long, slow death of people just starting to use other things, and it becomes irrelevant because of that. And so, I think a lot of Jupyter contributors and maintainers and leaders are highly motivated to understand what users need and serve them and build things that they love. And I think that ultimately, that's what drives people in our community to contribute and maintain and help us lead this.
Great. Well, thank you very much, Brian, for joining us today. I really enjoyed this conversation.
Thank you.
Thank you. And I just want to thank all of you for joining us. This has been Heather Joslin for the New Stack Makers on the road at JupyterCon in San Diego. We'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.